last but not least, let's see the concept of inheritance and how it allows to develop an object-oriented model in Julia. So here you can see we have one type, an abstract type, that is very general. We call it, just to be not much creative, my own generic abstract type, and is the highest level. Inheritance refers to the way that we organize our types from one very higher level and down to a tree of more and more specialized types. So let's going to create two new types that are child of our generic abstract type, and again, the names is not my top skills to find good names, so I call it my own abstract type 1 and my own abstract type 2, and by now you should know that this symbol means that we define this one as a child of this other type. And finally, let's going to define three concrete types. We call them a concrete type A, B, and zeta. And the first two are child of my own abstract type 1, and the third one is a child of my own abstract type 2, and they have different fields. Here the name is the same, but they could have different names and whatever as fields. Here I'm creating three different objects, instance of these three concrete types, OA, OB, and OZ. And with this syntax supertype, I can retrieve which is the parent type of whatever type I pass as argument, and the opposite is obtained with subtypes, where I can get the list of all the direct child of a type. Now, why we want to do that? Why we want to create this hierarchy of types? Because at this point we can use it to create functions that are more and more specific for our needs, because when we create a function with the same name but whose parameter as different types, and the multiple dispatch mechanisms of Julia allow to dispatch the function call to the stricter method, that is the one that is defined over the exact parameter type, or if this doesn't exist, their immediate parents. So let's see an example. So now I have this hierarchy of types with a concrete type 1, a concrete type B, and a concrete type zeta as my three instances of concrete types, with OA, OB, and OZ, the object that I created. Let's define a function foo of where the argument is A, and we define the argument to be my own generic abstract type and do something. We call it default implementation. For now, of foo there is only this function. So when I call this function with OA, OB, and OZ, it works because OA, OB, and OZ, they are all child of my own generic abstract type. But even if they are not my own generic abstract type, but they are child of my own generic abstract type, the function works. The call is dispatched to the function foo, and this is implemented, and I have the default implementation for all these three objects. Let's now going to create a more specialized implementation where I specify that this specialized implementation works only for parameter A that is of my own abstract type 1, so the first of the two abstract types that I declared as child of my own generic abstract type. So here I define my more specialized implementations. And when I'm going to call again foo with the free object OA, OB, and OZ, you can see that the first two, because they are child of my own abstract type 1, automatically the function that is applied is the more specialized one, a more specialized implementation. While for OZ, we still keep the default implementation because OZ is not child of my own abstract type 1. Finally, let's going to create another method, to add another method to the function foo. So we define again function foo, this time only for a concrete type A. And again, you can see that when I call it with OA, I have this new function that I defined, a even more specialized implementation. For foo OB, I have the intermediate one, so the specialized but not the more specialized implementation. And finally, for OZ, I still keep the default implementation because no one else method is matched. So when we have different possibilities, like for OA we have 3 methods that match the definition of the type of OA, and the one that is applied is always the most specialized type, more specialized method that is defined over the type or itself or its direct parents. Now, one important topic to consider, and the error that many people make, is that if it is true that a vector of integer is a child of an abstract vector of integer, and it's also true that an integer is a child of a number, what will happen if we ask ourselves, is a vector of integer is a child of a vector of number, or an abstract vector of integer is a child of an abstract vector of number? You will be tempted to say yes, of course, and instead the answer is false. So even if the container is a child and what is inside the container is a child of each other, when you put them together, attention that the two elements together, the container and the element and the type inside, are not child of this one on the right. And inheritance, as we see here, can be used to build object-oriented models, as we saw here. But another way is to use what is called composition. What is composition about? Instead of declaring one type as a child of the other, you define a type, and then you define one field to be of another type. Normally you do that where you define in your specific type the specific information regarding that type, and you delegate all the other information to the object that you reference in the object itself. That is, let's take this example. So here we have some shoes, and we define some properties, some fields for the shoes that are pertinent of something being a shoes. So here is a shoe type and the color of the shoes. And then we have another type person, and the characteristic of the person is the name and the age. And then we want to create students. So if we use inheritance, we define a student as a child of a person. But another way, based on composition, is to say, okay, I have a student, I'm going to define, the characteristic of my students, here schools, because the students go to a certain school, and then I'm going to, instead of repeating the name, the age, the color of the shoes, I'm creating two new fields, P for person, that reference a person object, and shoes, that reference a shoes object. In this way, I don't need to repeat the informations. I don't need to repeat the fields specific to person and shoes. And the same way, I'm going to create an employee, and employee again who will have a reference to a person and to the shoes, but while students has a reference as a field school specific to being a student, employee has two fields, monthly incomes and company, that are specific to the fact of being an employee. At this time I can create some objects. So I'm creating an object gym shoes that are type gym and white. I don't know, normal gym shoes are white, and pro shoes that are classical and brown. And then I'm creating two person, Mark, that is a student. And here you can see that in the constructor of the object, I'm putting here in the order that I defined the person. So Mark is a person, Mark 15, and then the other fields, so Divine schools, and I'm assigning some gym shoes to our student Mark. And then I am creating another object, Mr. Brown, that is employee. Brown is the name, 45, he earned 3,200 euros, he worked at ABC Corporation, and of course it uses Pro Shoes. This time, again, I can use multiple dispatch to define different functions depending on the type of person I have. So here I pass as parameter self, and this is just the name of the argument. I could have called it whatever name, and I say this must be a student of type students, and I print this string here. And here I use the same function name, but where the argument is an employee, and I print this other syntax. At this time, when I have Mark, you will see here that print my activity, it print the strings that we defined for students, and in particular, wait 1 second, I give an error. Yeah, because I didn't run it. Okay, so I didn't define it. So I have now defined the two functions, and with print my activity Mark. Hi, I am Mark, I study, wear blah blah blah, and I wear white shoes. And print my activity for Mr. Brown, it execute the correct function. Good day, my name is Brown, I work blah blah blah. So here is an example of how you can create a object-oriented model using composition instead of inheritance. There are other packages that allow you to use different object-oriented models, so based on specialization, for example person students, or based on weak relations, person shoes, or based on composition like a person and its arm. All this kind of object-oriented paradigm can be implemented using either the default tools provided by Julia or by third-party packages that I put here some links.